Hello, these are the answers for the review 7-1 to 7-3. Okay, so 1, make sure you know all of your vocabulary words from the first day of notes. So go back and make sure you understand tangent, secant, chord, radius, diameter, concentric, intercepted arc, central angle, inscribed angle, etc. All right, so for these first 6, sketch and label each of the following on circle O. If you've done this already, which you should have, you may have slightly different setup than I do, and that's fine. So radius OB. So draw a radius, that's O, here's B. There's number 1. Number 2, tangent AE passing through point B. So tangent skates right along the edge of the circle, right there, and then we're going to label that to AE. Passes through point B. Central angle COB. So I got to have a C on here somewhere, and I got to hit O and then B. So I'm going to put C down here. C. So there is the central angle COB right there. There's number 4. Inscribed angle CDF. Okay, C, it's got to start at C, inscribed vertex on the circle, and then it has to hit some point F, which I don't have up here. So, starts at C, hits some point D on the circle, and then can go somewhere off through F. So there's number 4 right in here. There's number 4. Oh, central angle COB. Maybe I'll label that one as 3. Okay, secant GF. All right, a secant is a chord that extends through the circle. So I can either make another one, or I could just extend out this one here that goes through F. There's a secant, and then we just label G down here. But you could have also drawn another one there, a really long line over here that goes through the circle, and labeled some point down here G. That would have been fine. And chord HB. Chord HB. So I need some segment that connects up with B. Let's put it here. H just has to be some other point on the circle then that connects up with point B. And that's it for those. These guys down here. Okay, in each circle, identify the special angle name of that angle, of angle 1, and then write a formula you would use to find the measure. So for number 7, this is a central angle. And that angle equals the arc. For number 8, that is angle 1 is an exterior angle. And the formula there is 1/2 of, or the angle equals 1/2 big arc minus little arc. Here's an interior angle. Angle equals 1/2 of arc plus arc of the vertical angle. 10, that's an exterior angle. Ice cream cone. And angle 1 plus arc AC, or that minor arc, equals 180. You could also say 1/2 the big arc minus the little arc is the angle. Number 11, another exterior angle. And the formula would be angle equals 1/2 big arc minus little arc. Number 12, inscribed. Angle equals half of its intercepted arc. And here's another inscribed. Angle equals half the arc. I'm going pretty quick through this, so if I'm going too fast, feel free to pause. If you don't need this, fast forward through. Okay, this set down here. Find the indicated angle or arc measure. Use colored pens, pencils, or highlighters to help you. So, angle 1 is a central angle, and I've told you angle 2 is 19 degrees. That's an inscribed angle, so its arc is 38 degrees, which means angle 1 is 38 degrees, because it's a central angle, same as the arc. Angle BAC is 34. And we want to find angle D, which is this angle up here. The diagram got kind of messed up there, but this is angle D. And this chord got shifted over. It's supposed to hit, I'm so sorry about that, here and here. Whoever made this, it wasn't me, didn't group the diagram together, so that's why it shifted. I always group all my segments together so nothing can shift. That means nothing to you. That's okay, just ignore it. Okay, so if this angle is 34, then this arc is 34. Angle D back here is an inscribed angle, so half of the arc. That's 17. Okay, angle D is 117 degrees. Find angle B. Here's a quadrilateral inscribed in a circle. So opposite angles are supplementary. So we'll do 180 minus 117. 63. Number 17. Arc BCD, all of this out here is 287 degrees. We need this piece down here. So 360 minus 287 is 77. Is that right? 360 minus 287, 73. Good thing I checked. 73. Angle 1 then is half of that 73. And half of 73 is 36 and a half. Okay, 18. Angle C is 57. Angle A. So again, these two are supplementary. 180 minus 57. 180 minus 60 would be 120, but I subtracted 3 too much, so 123. Okay, arc BC is 133. Here's the diameter, and we know it's diameter because it hits the center of the circle. So 180 minus 133 is 47. And then angle 1 is a central angle, so its measure is exactly the same as that arc, so angle 1 is 47. Bottom down here, let's see, that's an interior angle. So that angle is going to be half of its arc, 38, plus 21, half of 49, which is, let's add this again correctly, 59, which is 29 and a half. This one here, we have to find the measure of arc AB. This arc, I'm going to call that X. We have an interior angle, so that interior angle 65 is half of its arc, X, plus the arc of the vertical angle, 45. Multiply both sides by 2, makes this be 130. Multiply this side by 2, the half goes away, leaves us with X plus 45. And subtract that, X is 85. 22, exterior angle. Arc BD is 110. Arc BC is 36. That exterior angle is 1/2 of the big arc, 110 minus 36. 110 minus 36 is 74. Half of 74 is 37. Okay, moving on. Next page, 23. Arc ED is 58. BC is 12. We want to find angle CAB, which is this angle up here. That's an exterior angle. 1/2 the big arc minus the little arc. 1/2 of 58 minus 12 is 46, so that's 23. Measure of arc BC is 18. Arc ED is 78. Find angle BAC, another exterior angle. 1/2 of the big arc, 78, minus the little arc, 18. Half of 60 is 30. 25, arc BC is 28. Measure of arc DB is 100. And we want to find angle CAB, which is this one up here. Same thing, 1/2 big arc minus the little arc. 100 minus 28 is 72. 36. Angle 1 is an inscribed angle. Vertex is on the circle, so half of its arc. This is a semicircle over here, so half of 180, 90. Angle 1 here, this is that exterior angle formed by two tangents, or that ice cream cone situation. So we know this angle plus 130 equals 180. So that's going to mean angle 1 is 50. Here, angle 1 is an exterior angle, so we'll need 1/2 of the big arc minus the little arc. Big arc, if we follow the sides out, it's 63. Little arc, I need this one in here. I have a tough time finding that until we recognize this is the diameter. So top half up here, that's a semicircle, or 180 degrees. There's 163 right there. That leaves 17 for that. So we have 1/2 of 63 minus 17, 46. 1/2 of 46, which is 23. Looking at 29, exterior angle, 1/2 of the big arc minus the little arc. Here's the big arc. Here's the little arc. Okay, big arc, 160. Little arc, don't know. All right, but we know the whole circle is 360, and so far we've used up 270. So 360 minus 270, that's 90. That means this little bit in here is 90. 160 minus 90 is 70, which is half of that's 35. Angle 1 here. Oh, we have a bunch of diameters. That's awesome. We got this diameter. So 87 right here. 180 minus 87 is 93. Oh, and that's all we need because we have an interior angle. So that interior angle is half of its arc, 93, plus the arc of the vertical angle, 129. 129 and 93, 122. Half of that is 61. Uh-oh, did I add wrong? I did. Oh my goodness. 222. I knew that angle couldn't be 61 degrees. It's too big for 61 degrees, right? It's an obtuse angle. So I apologize for my addition here. This should have been 222, and then half of that is 111. Sorry about that. We all make mistakes, don't we? It's okay if we fix them. All right, now moving on. Away from the angles for a little while and back into segments in a circle. So we want to find the length of the chord that is 9 centimeters from the center of a circle with a radius of 15. So let's put a chord in here. Find the length of that chord. That's what we're looking for. It's 9 centimeters from the center. So remember, we're going to draw that perpendicular in from the center. That's 9 centimeters. Radius is 15. So your best bet here is to draw the radius to the end of the chord. There's your radius at 15. Let's use Pythagorean triples here. Let's see if it works. Divide out by a 3. That makes this a 3. 5. Yes. 4, which means this side's 12. The whole thing, the whole chord then is 24 centimeters. That 12 doubled. Okay, next one. Find the circumference and area of a circle whose diameter is 9.4 centimeters. Diameter, all of this is 9.4. Circumference, you can either use pi times diameter or 2 pi r. Since they gave us diameter in the problem, I'm going to use this one. Circumference is pi times 9.4. We'll just rearrange that. 9.4 pi. It says your answer should be exact. This is an exact answer. Typing up in your calculator gives you a decimal approximation. That's the exact answer. To find the area, pi times radius squared. Okay, radius is going to be 9.4 divided by 2. 9.4 divided by 2 is 4.7. For that I could probably done in my head, but that's all right. I'll do it up here for you guys. And then 4.7 squared, I can't do that in my head. That's 22.09. So this is 22.09 pi. And units for area are centimeters squared. Again, that's your exact answer. If you multiply out 22.09 times pi, it gives you a big, long, nasty decimal, and it doesn't stop there. It keeps going because pi keeps going. So we don't want a rounded off answer here because we asked for exact answer. All right, look at number 38. Find the radius of a circle if a 10-inch chord is 12 inches from the center. 10-inch chord. So here's my chord. That's 10 inches. And it is 12 inches from the center. We want to find the radius of that circle. Let me draw in the radius then. Always draw your radius to the end of the chord. That's what we're looking for. All right, if this whole chord was 10, then this half of it is 5. Oh, look at that. We have a 5, 12, 13. And your radius is 13 inches. Okay, 39. Two circles intersect and have a common chord of 24 centimeters. I'm going to put in that common chord there. That's 24 centimeters. It's kind of hard to mark that as 24. We're just kind of tuck it in your head. The centers are 21 centimeters apart, so I'm going to join the two centers. that distance, I can put that down here, that's 21. The radius of one circle is 20 centimeters. I have no idea which one it is. I'm just going to guess this one. That radius is 20 centimeters. All right, now we want to find the other radius. Okay, how long was this chord again? 24 centimeters. So if I take half of it by this perpendicular bisector right here, then this part's 12. Let's use triples. Let's see if I can divide by something. If we divide by 4, this becomes a 5 and a 3. Sorry, it's so tiny. Oh, that's 3, 4, 5, which means this part right in here, this blue part down here, that's really 16. All right, this whole thing down here, this whole distance was 21. That much of it was 16, so this green part down here, that's 5. Let's draw in the other radius. Oh, we got a 5, 12, 13. Okay? One more problem to go. But it's a doozy. Yay! Love these. All right, let's mark this diagram with the stuff we know. Arc AB is 100. Arc BC is 30. Arc EG is 50. That's what we have. All right, let's start using diameters to get the rest of the arcs. Remember, we're always going to do arcs first. So here's a diameter, 100, 30, makes this piece down here 50. I got another diameter right here. I got 30, 100, makes this 50 up here. And then that, 50, 50, that's 100, leaves 80 down here for this one. Okay. Next, we're going to do central angles. Central angles, vertex at the center. There's just angle 3, so if I follow the sides out, its arc is 50 plus 80, which is 130. After central, we're going to do inscribed. Inscribed angles, vertex on the circle, and they are half of the inscribed arc. Here's one, angle 5. Its arc for angle 5 is 100, so half of 100 is 50. Angle 8, follow the sides out. Its arc is 80, half of that's 40. Angle 2, half of its arc is 130. Uh-oh. Its arc is 130. Half of that's not 130. Half of that is 65. I said the half, but then I never did the half. 9, its arc is 130, so it is also half of that, or 65. Okay, let's find central inscribed. Interior. Angle 1 is an interior angle. Let me go do that over here on the side. Angle 1. Half of its arc, 130, plus the arc of the vertical angle, 50. Half of 180 is 90. Another interior angle, angle 6. Half of its arc, 50, plus the arc of the vertical angle, 100. Half of 150 is 75. Angle 6 is 75. I think that's all our interiors yet. So we should have 3 left. 4, 7, 10 for our exteriors. Okay, exteriors. Let's start off with angle 4. half of the big arc minus the little arc. Okay, little arc's right there. It's 30. Follow the sides out to the rest. That's 100. Half of 70, which is 35. Angle 7 is this one right up here. Half of the big arc minus the little arc. Okay, little arc's right there is 50. Big arc, I'm going to have to extend this side of 7 out. So the big arc is this 130. Half of 80, which is 40. And one more, angle 10. Oh, angle 10 is an ice cream cone situation. So half, not half, back up, I don't even need to do that. It's angle 10 plus the arc of 100 has to add up to be 180. So angle 10 has to be 80. And that's it. I hope that helped. If it doesn't, please join my Zoom meeting or send me an email.